Happy Tuesday, everyone. This video is for Eric Hill, my former Math 130 intermediate algebra student who's now a calculus student at Cal State Long Beach. Woot woot, congrats Eric, and he had asked me to do a video for his calculus class on one of the problems. So here it is, and I think it's also actually pretty relevant to my current calculus class as well. It's about antiderivatives, so it's the introduction to antiderivatives with some initial conditions. The question is find the antiderivative capital F of lowercase f, so find the antiderivative capital F of this function that satisfies the given condition. So first of all, I'm not sure how far along you are in your skill of finding the antiderivative. So I'm going to do a quick review of what is an antiderivative. So before we do antiderivative, I'm going to review what is derivative. So you're probably really familiar with finding a derivative. Step one is to multiply the exponent with a coefficient, and then you subtract 1 from the exponent. So for an example, if I had 2/3 x cubed minus 4x squared plus 7, if you wanted to find the derivative of this, so if this is f of x, then your derivative of this is where you multiply the exponent with the coefficient. So if you do that, you get 2/3 times 3, which is 2. Subtract 1 from the exponent, so you get 2x squared. Same story here, you multiply the 2 and the 4, you subtract 1 from the exponent, and the coefficient, or the derivative of 7 is just 0. So that's finding the derivative, which you're probably really familiar with. So the word antiderivative means against the derivative. So we're going to go in the opposite direction. So in other words, we're going to start off with the derivative, and then we want to find its original function. So that's what the antiderivative means. You start off with the derivative, and you want to find the original function. So when you do that, the steps are reversed. So here, step one is you're going to add 1 to the exponent. So the first step is to add 1 to the exponent. So you're going to reverse these steps, add 1 to the exponent, and then instead of multiplying, you're going to divide the coefficient with the new exponent. So for an example, if I start off with this, so this is f of x. So I'm going to start off with f of x is equal to 2x squared minus 8x. And I want to find the antiderivative of this. So the antiderivative is labeled as capital F. The antiderivative of this, I'm going to add 1 to the exponent, so I have x to the third, divide by the new exponent, so 2 divided by 3 will give me that. Minus, again, I'm going to add 1 to the exponent first, x squared, and then I'm going to divide by the new exponent. So 8 divided by 2 will give me 4. And then I always want to put a plus c, because if there was a constant here, when you take the derivative, it becomes 0. So that's why we want to put a plus c. So as you can see, 2/3 x cubed minus 4x squared plus c goes back to this here, 2/3 x cubed minus 4x squared. The constant, we don't know what it is, so we call it just a c. But here was a 7. So that's finding the antiderivative. So that's a quick review. I'm not sure if you needed to know that, but that's just a quick review of finding the antiderivative. It's going against the derivative, and then you're going to do the opposite steps. And you need to put a plus c to take into account the coefficient that became 0 when you took the derivative. So going back to this problem, find the antiderivative of this. So I'm going to first find the antiderivative of this here. So capital F of x is going to equal to, so I'm going to add 1 to the exponent, x to the 5th, and I'm going to divide by the new exponent. So I have the 5 here, but I'm going to divide by the new exponent, 5. So I get 5 over 5, x fifth. In other words, just x to the 5th. And then I have minus 4x. So I'm going to add 1 to the exponent, so I get a 6. And I'm going to divide by the new exponent, so I have 4 over 6. In other words, that becomes minus 2/3 x to the 6 when you simplify it. And then we always want to put a plus c to, again, take into any constant that had disappeared when you took the derivative. Let's just check our work real quick. So this way I always check my work. If I want to check my work, the derivative of f prime should give me the original function. So if I take the derivative of this, I would get, so take the 5, subtract 1 from the exponent, minus, multiply the 6 in front, 12 over 3 will give me 4x to the 5th. The derivative of c is just 0. So notice 5x fourth minus 4x fifth is the original function, so it works. So again, this is my f of x. This is my antiderivative. All right, so the question though is, what is c? So we can determine what is c by this initial condition. This is what we call the initial condition. And that will help us to determine what the constant c is. So here, since f of x is equal to this, if I plug 0 into this function, so f of 0, if I plug 0 in here, what am I going to get? I'm going to get 0 to the 5th minus 2/3 times 0 to the 6th plus c, right? So if I plug 0 into this function, it tells me that when I plug 0 in the function, I'm going to get a 6. So this is going to equal to 6. So knowing this, this will help me determine what c is. So this becomes 0, 0. So therefore, my conclusion is that c is equal to 6. Aha, c is equal to 6. So I'm going to plug the 6 back into here. So my answer then becomes x to the 5th minus 2/3 x to the 6th plus 6. Ta-da! If you need any clarifications, let me know.